Okay, in this video we're going to talk about Unit 6, Objective 2, Intermediate Value Theorem, and we're going to refer to that as IVT. What IVT states is that if f of x is a continuous function on some interval a to b, then every value, or f of x will take on every value between f of a and f of b. So what that means is if we have some graph, and we have some random continuous function that goes from the x value a to the x value b. We know that this right here would be the value y value f of a, because when we plug a into our function we get that f value out. And we know that right about here would be our function value f of b. So if we have some random function like we have here, all the intermediate value theorem is saying is if you take one endpoint and you look at its y value, and you take the other endpoint and you look at its y value, every single y value in between those two is going to be hit at least one time. So every y value here is going to be touched by your function at least one time. The intermediate value theorem does not tell you where each of those values happens, it just tells you that each of those values is going to happen. So if you are continuous, then you know you're going to hit every single value, y value, in between your endpoints. This is more than likely going to show up on a free response question. So we'll take a look at how you're going to see it and talk about the verbiage that you're going to need to use to answer your free response question properly. Alright, so you're more than likely going to see your intermediate value theorem or your IVT on a question like this. So we have a table of values, and the question would be something like if f of x is continuous on... So if f of x is continuous on the interval 1 to 4, is there a value c such that f of c equals 0? So what this is saying is we have some function and we want to know, is that function ever 0? So how we're going to answer this using our IVT is we're going to say, since f of x is continuous on our interval, and they tell us in the problem that the function is continuous. So since f of x is continuous on that interval 1 to 4, and our first endpoint, f of 1, equals -5, and our second endpoint, f of 4, is equal to 6, we know that there's a value, or there exists, we'll say, a c such that f of c equals 0. That's how we're going to want to answer this on a free response question. And the reason that this works, or the reason that we know that there's some value f of c, is our function is continuous, and our function starts at negative values, and the values of the y turn positive. So if there's any there's no way to go from a negative value to a positive value on a continuous function, meaning we don't pick up our pencil, without crossing the value 0. Now, when we're answering this for AP, there's specific things that AP is going to be looking for. They need you to say that f of x is continuous on the interval 1 to 4. If you don't state that we are continuous on the interval 1 to 4, you can't mention your intermediate value theorem. So we're going to say continuous on there and our two endpoints. That's the next thing we want to say. So we've established that we are continuous. We established our endpoints, and actually we should put in here by IVT. We know that there exists a c. So what AP is going to be looking for is they're going to be looking for you saying f of x is continuous, they're going to look for your endpoints, and they're going to look for you to say intermediate value theorem. Usually on these questions, the answer is going to happen. There will be a value c. They're very, very rarely asked this question and there not be a c. So they're going to be looking for you to say continuous, show your two endpoint values, and the value that they're looking for, here in this case 0, will always be between your two endpoints, so -5 and 6. So I guess when I was talking about this being a positive, we shouldn't have talked about that one. We should have talked about 0 and or -5 and 6. Same idea, but we need to use our endpoints, not just a random point on the interval. So that will do it for this video. We'll see you in the next one.